Chapter 7 of Is Mars Habitable? This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Is Mars Habitable? By Alfred Russel Wallace. Chapter 7. A suggestion as to the canals of Mars. The special characteristics of the numerous lines which intersect the whole of the equatorial and temperate regions of Mars are their straightness combined with their enormous length. It is this which has led Mr. Lowell to term them non-natural features. Schiaparelli in his earlier drawings showed them curved and of comparatively great width. Later he found them to be straight, fine lines when seen under the best conditions, but as Mr. Lowell has always seen them in the pure atmosphere of his observatory, both of these observers were at first doubtful of their reality, but persistent observation continued at many successive oppositions compelled acceptance of them as actual features of the planet's disk. So many other observers have now seen them that the objection of their unreality seems no longer valid. Mr. Lowell urges, however, that their perfect straightness and their extreme tenuity of their uniformity throughout their whole length, the dual character of many of them, their relation to the oases, and the form and position of these round black spots are all proofs of artificiality and are suggestive of design, and considering that some of them are actually as long as from Boston to San Francisco, and relatively to their globe as long as from London to Bombay, his objection that no natural phenomena within our knowledge show such regularity on such a scale seems at first a mighty one. It is certainly true that we can point to nothing exactly like them either on the Earth or on the Moon, and that these are the only two planetary bodies we are in a position to compare with Mars. Yet even these do, I think, afford us some hints toward the interpretation of the mysterious lines. But as our knowledge of the internal structure and past history even of our Earth is still imperfect, that of the Moon only conjectural, and that of Mars a perfect blank, it is not perhaps surprising that the surface features of the latter do not correspond with those of either of the others. Mr. Pickering's suggestion. The best clue to a natural interpretation of the strange features of the surface of Mars is that suggested by the American astronomer Mr. W. H. Pickering in Popular Astronomy, 1904. Briefly, it is that both the canals of Mars and the rifts, as well as the luminous streaks on the Moon, are cracks in the volcanic crust caused by internal stresses due to the action of the heated interior. These cracks he considers to be symmetrically arranged with regard to small craterlets, Mr. Lowell's oases, because they have originated from them just as the white streaks on the Moon radiate from the larger craters as centers. He further supposes that water and carbon dioxide issue from the interior into these fissures and, in conjunction with sunlight, promote the growth of vegetation. Owing to a very rare atmosphere, the vapors he thinks would not ascend, but would roll down the outsides of the craterlets and along the borders of the canals, thus irrigating the immediate vicinity and serving to promote the growth of some form of vegetation which renders the canals and oases visible. See footnote 13. This opinion is especially important because next to Mr. Lowell, Mr. Pickering is perhaps the astronomer who has given the most attention to Mars during the last 15 years. He was for some time at Flagstaff with Mr. Lowell, and it was he who discovered the oases or craterlets, and who originated the idea that we did not see the canals themselves, but only the vegetable growth on their borders. He has also observed Mars in the southern hemisphere at Arequipa, and he has since made an elaborate study of the Moon by means of a specially constructed telescope of 135 feet focal length, which produced a direct image on photographic plates nearly 16 inches in diameter. See footnote 14. It is clear, therefore, that Mr. Lowell's views as to the artificial nature of the canals are not accepted by an astronomer of equal knowledge and still wider experience. Yet, Professor Pickering's alternative view is more a suggestion than an explanation, because there is no attempt to account for the enormous length and the perfect straightness of the lines on Mars, so different from anything that is found either on our Earth or on the Moon. There must be evidently some great peculiarity of structure or of conditions on Mars to account for these features, and I shall now attempt to point out what this peculiarity is and how it may have arisen. The meteoric hypothesis. During the last quarter of a century, a considerable change has come over the opinions of astronomers as regards to the probable origin of the solar system. The large amount of knowledge of the stellar universe, and especially of nebula, of comets and meteor streams, which we now possess, together with many other phenomena, such as the constitution of Saturn's rings, with the great number and extent of the minor planets, and generally of the vast amount of matter in the form of meteor rings and meteoric dust in and around our system, have all pointed to a different origin for the planets and their satellites than that formulated by Laplace as the nebular hypothesis. It is now seen more clearly than at any earlier period that most of the planets possess special characteristics which distinguish them one from another, and that such an origin as Laplace suggested, the slow cooling and contraction of one vast sun-mist or nebula, besides presenting inherent difficulties, many think of them impossibilities, in itself does not afford an adequate explanation of these peculiarities. Hence has arisen what is termed the meteoric theory, which has been ably advocated for many years by Sir Norman Lockyer, and with some important modifications is now becoming widely accepted. Briefly, this theory is that the planets have been formed by the slow aggregation of solid particles around centers of greatest condensation. But as many of my readers may altogether be unacquainted with it, I will here give a very clear statement of what is from Professor J. W. Gregory's presidential address to the geological section of the British Association of the present year. He began by saying that these modern views were far more practical to use of men of science than that of Laplace, and that they give us a history of the world consistent with the actual records of geology. He then continues, according to Sir Norman Lockyer's meteoric hypothesis, nebulae, comets, and many so-called stars consist of swarms of meteorites, which, though normally cold and dark, are heated by repeated collisions, and become so luminous they may even be volatilized into glowing meteoric vapor. But in time this heat is dissipated, and the force of gravity condenses a meteoric swarm into a single globe. Some of the swarms are, says Lockyer, truly members of the solar system, and some of these travel round the sun in nearly circular orbits like planets. They may be regarded as infinitesimal planets, and so Chamberlain calls them planetesimals. The planetesimal theory is a development of the meteoric theory, and presents it in an especially attractive guise. It regards meteorites as very sparsely distributed through space, and gravity as powerless to collect them into dense groups. So it assigns the parentage of the solar system to a spiral nebula composed of planetesimals, and the planets as formed from knots in the nebula, where many planetesimals had been concentrated near the intersection of their orbits. These groups of meteorites, already dense as a swarm of bees, were then packed closer by the influence of gravity, and the contracting mass was heated by the pressure even above the normal melting point of the material, which was kept rigid by the weight of the overlying layers. Now, adopting this theory as the last word of science upon the subject of the origin of planets, we see that it affords immense scope for diversity in results depending on the total amount of matter available within the range of attraction of an incipient planetary mass, and the rates at which this matter becomes available